Rolling Shutter Wobble Vision presents... Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. Okay, it's Cool Dude Clem and I've been tubing again, doing more experiments with tube amplifiers. Yes, I've gone and built another one. Again, this is a single-ended Class A. But I thought I'd use both sides of an ECC 83, otherwise known as a 12XA7, and an EL 84, I've forgotten what that's known overseas, but happy to say it works and it is very sensitive. Of course, I will put up a schematic diagram. It works and it sounds really good. The only problem is it's a little bit hummy. Microphone right there on the speaker. You might be able to hear that. And my webcam appears to be behaving, so that's good. I threatened it with buying a new webcam, and it seems, ever since then, it seems to be working just fine, so yeah. And people watching this who are going to post on the CWiki forum saying all offensive stuff about me, go ahead! Go ahead, I say. Everything you say is all bollocks. There, I said the B word, because I'm not offended by that one. And I'm not listening to anything you have to say. You think this is going to stop me making videos? By twisting all the facts about me and getting a lot of things wrong? Well, you're wrong. Anyway, now that's off my chest. I have the tape. Go play a song from the Reel to Reel. One of my own songs, actually. Really got to get on with that video about how I do my music, but anyway, let's give this a little listen. There it is. Let's adjust the volume control. It does go pretty loud, but I don't really want to disturb the neighbours with it. Oh well, there we go. Kind of timed that just right. The music ended right about the same time as the end of the demonstration. Anyway, I think a schematic is in order now. Okay, so here is the schematic of the amplifier that you just heard. But anyway, it's a basic two-stage, well, three-stage actually, three-stage amplifier. Using two tubes, we've got ECC 83 over here and an EL 84 over here. So basically it comes in, gets amplified by this part of this tube here, then that goes into this variable resistor, it gets amplified again by this part, end of the tube, side of the tube, then it goes out into the EL 84 where it's amplified to the speaker. And that's basically it. Anyway, I want to move on a little bit and make a double-ended amplifier, because, you know, I've pretty much mastered the technique of making single-ended amplifiers now. Right, so this is the schematic of, well, work in progress schematic of a double-ended valve amp that I'm going to make. I haven't drawn in the preamp or anything like that. This is just the output stage. So anyway, you can see I've got two back-to-back. They're mixed via this transformer here. The supply voltage comes in here, where it goes into the transformer, but also we've got 10k resistor here and a capacitor here just to provide voltage for the second grid. And that also goes off to power this tube here, which I will talk about in just a minute. We'll see what that does. And to bias these tubes, I've decided to use grid bias. So, got a variable voltage supply here, and that feeds a negative voltage into the grid of these two tubes via these two resistors. So I can adjust the bias. Now the only trouble is, if I was to feed an audio signal, the same audio signal, into both of these tubes, or valves, or whatever you want to call them, it won't work because they would both be amplifying the same. And they would be fighting against each other. As the audio signal goes positive, they would both conduct more and would be cancelled out at the transformer. And the same goes for when the audio signal goes negative. They would both conduct less and, again, cancel out at the transformer. I think I just knocked the camera, but it doesn't matter. So what we got to do is invert the signal to one of these, and that's what this thing here does. So this one is connected up to an audio signal, got a resistor here and a resistor here, and these two resistors are make up exactly the same resistance as this resistor here. The only reason why I haven't used a 50k resistor here as well is because, well, I need a smaller resistance there as well to bias the tube, so it's sort of in its halfway position. So anyway, as the audio signal goes positive, this tube will conduct more, and the voltage here will drop, and the voltage here will rise. And when the audio signal goes negative, this tube will conduct less, so the voltage here will rise, and the voltage here will drop, and what we get is an inverted signal going into this tube, and a non-inverted signal going into this tube, or valve, or whatever you want to call it, and problem solved. Although we do lose a little bit of audio signal around here. But then I can put an extra stage of amplification in if I need to, so that's no big deal. Okay, well, just before I take this down, I thought I'd show something a bit interesting. Now, there's a hole, a window, in the plate of the EL84, and I don't know how well you can make that out, but you can see that the inside of the plate is actually fluorescing blue, which is kind of strange. You can see, like, those are little blue bars in there. I mean, obviously the grid is making it so it's not just one solid block. I thought that was kind of weird. And we can see it from the other side. You can kind of see it a bit better here. The inside of the plate glowing. Don't know if that's normal or not, but I just thought I'd show this because that's kind of interesting. As you can see, when I turn it off, the glow disappears. Look at that. That EL84 has really zorched the carpet there. Better be a bit more careful next time. Now we're going to do some experiments with the phase splitter circuit. So I've got 47k resistor here, 47k variable resistor here, and the center tap of that goes into this 1 megohm and then into the grid. So, hope the camera's still behaving. Turn this on and measure some voltages. I'm going to put this in the middle of its range. There we go. So turn on. Wait for this to warm up. Is it on? Oh yeah, I can see it. I can see if the filaments were glowing. Of course, I don't think the camera's going to pick it up. I'm just going to wait for that to warm up and just run a few little tests. Hopefully not electrocute myself in the process. Okay, so first we're going to test the voltage between the ground and the cathode, which is right here. We've got about 7.5 volts. It's our supply voltage. 374 volts, and that's a bit high. I just realised I've put my power supply on the high setting, and the high power setting. Alright, we'll have to redo that again because I had that on the other setting. Oh, great. Okay, so that's dropped down to about 6 volts now, because our supply voltage is now about 290 something volts, although it seems to be climbing, which is a bit weird. I don't know why it's doing that. That's weird. Very weird. So anyway, as I adjust this, we should be able to adjust the voltage. The bias. We should see a change in the voltage. As you can see, to turn it that way, the voltage goes down as I expected it to. Turn it this way, the voltage goes up. See how far that goes up. About 91 volts. So I'm going to put this on to about 20 volts. Just about there. So we got 20 volts at the cathode. Let's see what voltage we've got at the anode. Okay, 330. Let's see what the voltage is across the resistor. We've got about 22 volts across the resistor. That's what I expected it to be. And across this variable resistor, we've got roughly the same. Okay, now I'm just going to keep measuring between the ground and certain points on the thing because that's going to be easier. So, as you saw, as the tubes, as the voltage here increases, I can increase the voltage by doing that, the voltage here should decrease. So I've put the resistor back onto 20. So let's measure what we got here. And the voltage here, when I turn the potentiometer up, should go down. Well, it will go down, but let's see that in action. There we go. As you can see, dropping like a stone when I turn up the voltage. Working exactly the way that I hoped it would. Okay, so I'm going to set this to about the halfway point. So let's set that to about 40 volts. That should be plenty enough. Alright, there we go. 44 volts. That's pretty much good. Well, here we are. Here is my design. Here's my fantasy come to life. Okay, here it is. Using two EL84s as the outputs. They're both Tesla brand because I want to make sure they're closely matched. I don't know how closely matched these two are, but hope they're closely matched enough. I've got one ECC83, which I'm using one side of that as a preamp and the other side of that as the phase splitter. The only thing that's not all that good is the transformer. This is the only one I could find that's got a center tapped primary. So that's probably where the only weakness of this thing is going to be, with that tiny little transformer. But it's the only one I've got that's got a center tapped primary, so I'll have to do about 200 ohms between here and here, and about another 200 ohms between here and here, so that should be plenty enough. Shall we turn this on, see if it works? Yeah, why not? I don't even know how well this is going to work. Okay, well I'm going to have to reshoot this bit again because I thought that the meters display was on the video, was, you know, in the shot, but when I play the video back, I find it's not in the shot. It's like sort of about there. I sworn it was in the shot, but still. So anyway, we've got this warmed up and it does seem to be working. Although I'm only powering this on the current limited mode at the moment, which some of you may remember there is a resistor between the transformer and the rectifier in my power supply to limit the current. Anyway, all the tubes are warmed up, so let's take some voltage readings. Our supply voltage, which is going into this transformer, is at the moment about 316 volts. So that's our B plus. Seems to be jumping around a bit for some reason. I think it's just not connecting very well with the meter. Our A supply, which comes from this resistor here, we have 294 volts. At the transformer, it's about the same. So it's very little current going through the tubes. And I'm using my homemade power supply to supply the bias for the two output tubes, and I've set that to about 30 volts. So I've measured the grid of one of these. You can see right there, hopefully my hand's not blocking it. We've got about 28. Okay, so I'm just going to clip this on the end of the meter's test lead here. Like I was showing it in the camera. So there we go. It's not the best connection, but it'll do, because I don't have a crocodile lead long enough. Okay, I'm just going to connect that to the positive, like that, so we can see our supply voltage, which is 315.8 volts. And even though I haven't got everything set up properly, it does amplify. This wire's going into the preamp stage of the amplifier. And if I just touch the end, see if I can get the speaker in the shot as well, you might be able to see we have quite a bit of amplification there. And you can see when that did that, it pulled the voltage down a little. Okay, well, I'm trying it with an audio source, but I'm getting absolutely nothing. This is a really perplexing thing here. I don't know what's going on. I've got it connected up to my reel-to-reel. I don't know why, just lately this camera is, like, the frame rate keeps going bonkers. Mind you, this camera's bonkers anyway. I'll start the tape. Excuse the mess. Nothing. I mean, I've got this directly connected without any potentiometer or anything right onto the grid of the preamp section, and I cannot hear a single thing. Let's see, we've still got good voltage. I don't know why. I'm going to see if I... Just going to back the bias off a little bit, give it a little less bias, see if that does anything. Oh, wait. Ah, there we go, that's the problem. Too much bias. Okay. Getting a little bit of hum, but got some music playing. Yeah, we got some music playing through it now. Okay, I'm just going to turn the bias down some more. Yeah, that sounded pretty distorted. Now I'm going to put this onto the full power. So this is unlimited. Oh. Okay, again. Okay, we're getting a little bit of hum. I don't know if that's from my power supply or not. It works! I'm a genius! Victory dance! Okay, we're going to try and get the bias adjusted. See what the ideal bias voltage is. Now, I've got this meter measuring the plate voltage and this meter measuring the plate current of one of the tubes or valves. At the moment we're at 358 volts and about 13 milliamps. So I'm going to stop the reel-to-reel playing, which has got some music on it. Excuse the mess as usual. Now I've deliberately turned the bias down too much, so I'm going to adjust it now and see where it sounds best. Right about there, I think. That's about the best I can get it. Just needs a bit of fine tweaking. Yep, I think that's just about it. figured out why it's sounding distorted at times. Yep. Yeah, meter's dropping too much current, that's the problem. Okay, so let's see what our bias voltage is. I have to take this amp meter out of the circuit because it was dropping the voltage too far on one side of the transformer. That's why it was sounding distorted just then. Okay, I'm going to turn the bias voltage up a little bit. Okay, going to put that to about 20 volts. Turn on the power. So let's see where this sounds best. Let's wait for it to warm up. Okay, so this is with about 20 volts bias. I'm going to start dropping the bias voltage now. 17. That's about 6 volts of bias. So there we go. I'm gonna call this a day. Anyway, here is the schematic of the amplifier so far. Here is the ECC83. There's one side being used as the preamp, the other side being used as the phase splitter. There's the potentiometer to set the phase splitter to its halfway point. And then, of course, like in the previous schematic you saw, that goes out to these two valves, or tubes, whatever you want to call them, which are both EL84s, and into the speaker. And as you heard, it works rather well. In fact, I'm surprised it worked at all, because I didn't really have the highest expectations for this, but guess I proved myself wrong. Okay, so now we're going to find out exactly how much of a match this transformer is for the EL84s. Some people say me dumb because me not do math. Well, or maths. Maths has got a s on the end. Right, so firstly what we're going to do is measure the AC voltage. And of course, I'm sure most of you will know what that is already, but let's put this onto AC volts and measure the voltage that comes out of the power line here. Okay, so we now got that plugged into the meter, and we've got about 241 volts. So now we want to measure what the voltage coming out of the transformer is. With this transformer, it's perfectly safe to connect it up to mains because it is a mains transformer anyway. So let's see what the voltage is that we get out. Okay, here we go. It gives us about 19 volts. That's a little bit more than what I thought it would do actually. I thought it'd be more around 9 volts, but okay, so now we are going to do just a little bit of maths to find out how much load the transformer's putting on the valves. Okay, so we know the input voltage is 241 volts across here and here. We know the output voltage is 19.2, so let's get the turns ratio. So calculator. My modified calculator here, so 241 volts divided by the output voltage, which is 19.2, and we get ratio of about 12.5. So that's the total turns ratio. I can already see that this transformer is it's totally not right for this kind of tube, but let's see what we get anyway. So turns ratio found out is 12.5, so kind of hard to write holding the pen at this weird angle like this that I'm having to hold it at. So now we've got to find out what the turns ratio between the center tap and one end of the primary, what the turns ratio of that is, and that's very simple. We just divide that by half, or half, you really want to say it in a British accent, and we get about 6.25. So from one side of the primary to the secondary, the turns ratio is 6.25. Now what we've got to do is multiply that number by itself to find the impedance ratio. So 6.25 times 6.25, and we get 39. And then all we got to do is multiply that by the speaker impedance, and we've got our number of how much load it puts on the tube. So let's see, at 8 ohms, 8 times 39 is 312 ohms, and at 4 ohms, 39 times 4, 156. I think I just pulled the calculator away before I actually showed it. And that is way short of what we actually want, because those EL84s really want an impedance of about 5.2 kiloohms, and, well, you can see right there, it's nothing like it. So anyway, next thing to do is got to find a much better transformer that's a much better match than this little thing. I mean, that's just another power transformer. But all in all, I'd say that's a 100% successful experiment. Until next time, goodbye. Well, hello and welcome to another episode of Tube Time on Cool Dude Clem's Electronic Workshop. Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. Now this is about the 400 millionth time I've recorded this commentary because the stupid connector for the microphone keeps not working. So I was just going, and you couldn't hear a word I was saying. Anyway, in today's episode of Tube Time, I'm going to build 3 tube preamps, and we'll see which works the best. So, let's meet the tubes. We have a 12AE7, which is a dual triode, a 12EC8, this one's a triode pentode, and finally a 6N3P, another dual triode. And this is the one I'm going to try first. This is the circuit that I'm going to build. It's based on this circuit here, except I have removed the load resistor and the output capacitor because I'm going to connect this directly to my scope, and I can just simply put my scope onto AC coupling, so I don't need that capacitor. Anyway, normally with tube circuits, the supply voltage will be between 200 and 300 volts. However, the more observant of you might have noticed, 12 volts. Yep, only gonna operate this from a 12 volt supply. Got this biased grid, and we got this grid biased in an unusual way because it's biased positive instead of negative. And it's biased positive by these 2 resistors here. And the thing is, if you make the grid positive so it attracts electrons, you can power the tube from a low voltage, but personally I haven't had any luck with those kind of circuits, and I really don't think this is going to work either, but let's build it and find out. Okay, so here's the setup for this experiment. So on the breadboard here I've got a sine wave oscillator that puts out about 1.5 kilohertz, and this control here controls how much output we have. It's basically a volume control. So out from the potentiometer it goes into the tube and also into one channel on the scope, which I should really point the camera at before I say anything. I've also got the output of the tube connected to the other channel on the scope, and also a secondary camera right here so we can see the waveforms more clearly. So anyway, we're going to turn this on. It's all powered from my homemade power supply right here. So let's turn on and see what we get. Okay, you can already see the output from the oscillator right there. Wait for the tube to warm up, and it looks like we got a bit of a bad connection there. Okay, tube's warming up. I don't know why the output has suddenly jumped down a little bit. Let me just okay, I think we had a bit of a bad connection there, but everything seems to have sorted itself out. So anyway, I've got the scope on 0.2 volts per division. I'm just going to move this waveform up a little bit so I can count the voltage more easily. So we've got 0.2, 0.4, almost 0.5 volts going into the tube, and just look at that output waveform. That is not good. That looks terrible. Okay, so I'm now going to turn down the output waveform. Let's see if we can get a good sine wave. Okay, I've got this on 20 millivolts per division. This one here, I've got that on 20 millivolts per division. So let's see what the voltage is. We've got 20 millivolts, 40 millivolts, about 60 millivolts in. This one is set to 10 millivolts per division, so we're actually getting less right here. If I put these both onto 20 millivolts per division, you can see this thing is really just not going to amplify at 12 volts. Okay, so the next tube we're going to try is the 12AE7. And you know the crazy thing about this tube? It's actually designed for 12 volt high tension. Again, I'm going to use exactly the same circuit, except we don't need that resistor, so I'm just going to take that out of the circuit and we'll see how this works. Alright, so this is what's going into the tube from the sine wave generator. I've got this on 2 volts per division, so that's 2, 4, about 5 volts, well, about 5.5 volts. And this is the output from the tube, and I've got this on 5 volts per division, so that's 5, 10, so about 12 volts there. So let's turn the amplitude down to where this isn't distorting anymore. Okay, it's getting nice and sine. Zoom into the input. Let's just move that there. Let's just move that there. Okay, looks like the input waveform's bigger than the output waveform, but the output waveform's actually much larger. I've just got that zoomed out. Got this set on 0.2 volts per division. I've got this set on 5 volts per division, so we're getting about 10 volts peak to peak out of the tube, which is really good. That's a lot more than I was getting out of the other tube. I don't know why, but for some reason my input voltage and my output voltage seem to be going up and down at random. It's kind of weird. So I've got 0.2, 0.4, so about 0.44 volts going in and about 10 volts coming out. So let's crunch some numbers and see what we've got. So we have 10 volts coming out the tube. Let's divide that by what's going into it, which is 0.44 round about. It's a bit hard to tell because I must have a loose connection on my breadboard somewhere, but that's approximately what we have. So let's see how much amplification we have. 22. That's actually pretty reasonable. And now finally the 12EC8. This one is also a 12 volt high tension tube. Using the same circuit, except I'm going to just need to make a couple of minor changes since this part of the tube is a pentode instead of a triode. So let's just add the grids. It's going to be a bit difficult since the way this has been drawn, but let's add a screen grid there, and a suppressor grid there, and the suppressor grid is internally connected to the control grid, so I can just draw that in like that. And I'm going to connect the screen grid. It's a bit weird to draw when you're holding the pen sort of against a vertical wall like that. But yeah, gonna connect the screen grid directly to the 12-volt supply. We'll see how this goes. Anyway, here we are with the 12 EC8, and it is definitely seems to be amplifying. This is what's going into the tube, and this is what's coming out of the tube, or valve, or whatever you want to call it. It's so much amplification there, my scope cannot show it. So just this here. Now I've got that on 1 volt per division, so that's 1, 2, 3, about 3.4 volts peak to peak. And this is the output from the valve. As you can see, it is way overdriven. And I've got that on 5 volts peak to peak. So let's see what the actual voltage we're getting out of that is. 10 volts peak to peak. But as you can see, that is a major clipped square wave there. Alright, so I'm going to turn down the oscillator until this stops clipping. Okay, there we go. Okay, we got a sine wave there now, more or less. There seems to be a little bit of non-linear distortion going on there, but there's a little jumping around a bit. We got some 50 Hertz crap going on as well. Not much I can do about that. Let me just zoom in on there. And let me just zoom in on the oscillator waveform. This is the output from the oscillator. I've got that on 50 millivolts per division. This is the output from the tube. That's 50 millivolts. That's about 75 millivolts peak to peak there, going into the tube. And coming out of the tube, we have, let's see now, I've got that on 2 volts per division, so that's 2, 4, 6, about 6 volts peak to peak. So there is definitely quite a bit of amplification going on there. Let's see if I can get that to become more of a sine wave. No, I think we're going to get that non-linear distortion no matter what. Alright, so let's go to my vintage calculator here and see exactly how much gain we have. So we had 6 volts peak to peak. Let's divide that by what our input voltage is, which was 75 millivolts, and we have 80. That's actually a lot higher than what I expected. Okay, here are the test results from the 3 amplifier circuits that I built. So, each tube at 12 volts, the 6N3P gave us no amplification. In fact, I'd say it cut the voltage in half. The 12A7 did much better. We got 22 times amplification there. But the winner overall is the 12EC8 with a whopping 80 times amplification. So what I'm going to do is build up that little preamp again, connect it to a microphone, and we'll see how well it works. Okay, so this is the 12EC8 being used as a microphone preamp. And to prove that this is only running on 12 volts high tension, this wire here is where the supply voltage is coming in, and that is powering both the filament and the plates. This 9 volt battery, all that's doing is it's just providing the power for this little microphone. However, as you can probably hear, the sound quality there's quite a lot of background noise. And despite that 80 megabytes, that 80 times gain, I've really had to crank up the input so I can hear from this thing. It's absolutely crazy. So anyway, that's just about it from me. And until next time... Oh wait, I forgot to mention something. So anyway, when I come to edit the video, what I'm going to do is I'm going to play the sound from this tape into the computer so you can hear what this sounds like. And anyway, that's just about it for now, because I'm running out of space, I'm running out of camera stunt, I'm running out of camera battery, my mouth is running dry, I really need a drink, so until next time, yeah, you know the rest.